A customer opens a ticket saying they never received the event. You check, and your logs say you sent it. Their logs say nothing arrived. Both of you are probably telling the truth, and neither of you can prove anything because the whole delivery existed as one HTTP call that either happened or did not. Webhooks look like the simplest integration you can build, right up to the point where you are delivering to a few thousand servers you do not control and cannot fix. So let's design that properly. The obvious version sends the webhook where the thing happened. An order is created, and right there in the same block of code, you post it to the customer's URL. Two problems, and the small one is obvious. Your transaction now runs as long as the slowest customer's server takes to answer, so one timeout in someone else's infrastructure becomes latency in your checkout. The bigger problem is that you are writing to two systems that cannot agree. Commit the order and then crash before sending, and the event never happens. Send first and then fail to commit, and you have told the world about an order that does not exist. There is no ordering of those two writes that is safe because they are separate systems with separate failure modes. This is the dual write problem, and no amount of careful try-catch removes it. You can only remove it by making one of the writes not be a write to another system. So instead of sending, record that you intend to send. In the same transaction that creates the order, insert a row into an outbox table describing the event. One transaction, one database. So either both facts are true or neither is. Then a separate relay process reads unsent rows from the outbox and delivers them, marking each one when the customer acknowledges. Now a crash anywhere is survivable. If it happens before the commit, nothing occurred at all. If it happens after, the row is sitting in the outbox and the relay picks it up whenever it comes back. That is the transactional outbox, and the shift is subtle, but total. Delivery is no longer an action taken during your business logic. It is a piece of durable state that a background process is responsible for driving to completion. Now the delivery itself, against endpoints that will be down, slow, and occasionally wrong, retry with exponential backoff, and add jitter, because 1,000 deliveries that failed together will otherwise retry together and hit their server as a synchronized wave the moment it recovers. Cap the retries, and then keep the event rather than dropping it. The part that matters most at scale is isolation between customers. If one customer's endpoint hangs for 30 seconds on every request, and your workers pull from one shared queue, that single dead endpoint will occupy your entire worker pool and delay everybody. So track health per endpoint and open a circuit when one keeps failing, parking its events aside instead of retrying them through the shared path. And be honest about ordering. Once retries exist, event 2 can land before event 1. Rather than promising an order you cannot keep, put a sequence number on every event and let the receiver decide what to do with one that arrives out of turn. One side is left, and it is the side you do not build, theirs. A webhook is an unauthenticated request arriving at a public URL, which means anyone who learns that URL can post to it. So sign the payload, compute a signature over the exact raw body using a secret you share with that customer, and send it as a header and tell them to compare it before trusting anything. Include a timestamp in what you sign and have them reject anything old. Otherwise, a captured request can simply be replayed later. Then give them an event identifier and say plainly in your documentation that you deliver at least once and they must be idempotent. Because everything we just built guarantees duplicates. Finally, expose a delivery log they can look at themselves, showing every attempt and every response code. That is what turns the ticket we opened with into something either side can settle in a minute. The outbox, the dead letter channel, the idempotent receiver, and the circuit breaker are all named patterns with decades of use behind them, and each has cases where it is the wrong choice. The Enterprise Integration Pattern Series works through them with the trade-offs attached. That is where to go next.